Yeah, thank you very much for your introduction. My name is Sasao. This April, I moved from the Kyoto University to Okayama University. But before that, for that 30 years, I was at the Kyoto University at the Department of the Physics. My specialty is an education on the laboratory. And as Dr. Wyman talked about the magnetism. So that this is one of my subspecialties. I taught this subject for about 10 years. My specialty is experiment. So I am very much interested in laboratory education or the experiment-based education. There are the experiments and good for the third grader and the fourth grader during the summer vacation. Separate from the credit system, I tried the different experiments in order to understand the response and feedback from the students. We really enjoyed a very good response from the students, this kind of the free experiments not related to the credit. So today I'd like to talk about the issues and see from past experiences in the physics education. So I would talk about not only the methodology of the laboratory education, but then I'd like to talk about the trends of the science education in Japan. Professor Bando has already talked about at the personal level, the creativity is quite important in order to motivate students. And throughout Japan, there are a number of the efforts made by so many teachers. But we cannot depend upon the individual efforts made by individual teacher because the challenges we are facing is great. So under such a trend and a situation, and what kind of solution we can seek. So that this is what I'm going to talk about during my presentation. So I became interested in this kind of subjects about 20 years ago. At the Japanese Physics and Society. So that at 20 years ago, I was a chair of the Kyoto chapter of the Japanese Physics and Society. So I wonder what kind of project that I have to do. So I picked up what is physics and education at the high school in Japan. So I am interested in that. So that within the Kyoto Prefecture, Shiga Prefecture, and Nara Prefecture, I interviewed 30 physics the teachers from the high school, and interview session lasted 5 or 6 times, and there was an amazing findings. So that the high school physics teachers they are specialists, and they are just teaching the physics, and the chemistry teachers teaching physics. This is what I thought. But 20 years ago. So except for the one student, one teacher, the teachers interviewed taught more than one subject. So that there is no specialist of the physics. That is why a biologist teacher or the chemistry teacher had to teach physics. So that the physics teacher talked about the technology, information technology, in many cases. So that there was, there is only one the teacher who was specialized in the physics. So the other teachers had to teach more than one subject. So it is very surprising. The finding, and which made me really concerned. So that from that experience, I became very much interested in this kind of topic. So my concern is about the lack of motivation on the side of the students. This is the statement from the Dr. Shinichiro Tomonaga, together with Dr. Yukawa, about 110 years ago. He was born about 100 years ago, and both of the two remarkable scholars studied at the Kyoto University, and both of them obtained the Nobel Prize. So the quantum electrodynamics is so that the specialty field of the Dr. Tomonaga, so that for his winning of the Nobel Prize. So this is a statement: to wonder mysteries of the nature is a buzz of science in your mind. Observe and ponder them over. For stem of the science in your hand. Finally, you unravel the roots to see the blossom of the science in the world. So the most important starting point is to wonder mysteries of the nature. But this sense of the wonder is fading away. So even if we talk about a very interesting, so that the wonders of the so the nature or natural phenomenon, even if I show a very elegant and a cool gadget, and people are not impressed. So the people are not interested. So that I am very much concerned about the students' apathy. So that during the lunchtime, I talked with Dr. Bando. I wondered how the blue sky would be generated, and this is so that as a result of the polarization. And so that in the electromagnetic field students, I went out to the outside, and we so that delivered sunglasses and studying polarization. So for the initial years when I started, 15 years ago, when I started this methodology, and then many so that the students so that are fighting with each other in order to try to put on the sunglasses. But nowadays, the students seems to be very indifferent. They don't care. So I think this is a great change of the attitudes of the students. So how to motivate the students? This is the key. So how to address the motivation issue is the critical point for the science education, especially physics education. So before advancing my presentation, I'd like to show you the result of the several surveys. So that there is a TIMSS survey. So that in TIMSS survey, so that Japan and Taiwan, Korea, and those Asian countries, and those students are so that are getting really high scores in the examination within the TIMSS system. Japan's score is good. But what is surprising is to the question, do you enjoy the science classes? I think this was, this is a survey of the 2003. So that toward the so that the second grade of the junior high school, strongly agree, and strongly disagree, and this is Japan. And about 50% of the students answered so that don't think so. And another question is, do you want to get a scientific job in the future? I don't think so. 40% of the students. So that only 40% of the students answered yes, and 60% of the students answered no. So that do you enjoy the science classes, and do you want to get a scientific job in the future? Those two questions are related to each other. This is the position of the United States. So the Japan and the Korea. So that the position is very low, although so that the performance or the achievement of the tests of the both of the Asian countries are really high, but their so that the attitude about the science is very low according to the TIMSS survey. And so this the attitude of the hate science. So that this is giving a great impact on the universities, and this is a survey from the Ministry of the Education of Japan. So that this is in 1988, about 20 years ago. So that this is the trend of the applicants for the science and the engineering departments. So that in both of the departments, the number of the applicants has been dropping. But this downward trend is more marked when it comes to so that the science. So that although the birth rate is sort of dropping, but more and more sort of high school graduates that advance to the universities, but less students want to study science or engineering. So this is a survey from the national government of Japan. So that this is a literacy, science literacy among adults. So that this is a survey done by OECD. This was rather old, back in 1991. So that those are the questions and the general public have to answer. Number one, in the core of the core part of the Earth, the temperature is really low, yes or no? And the answer is yes. Yeah, this is really always high, and the answer is yes. And then the laser is obtained by converging the sound. The answer is no. So that this is not a sound, but a light. And number 6 is that the size of the electron is smaller than that of atom. And yes, and this is correct. And the last one. So that milk contaminated with the radiation, so that can be made so that safe after boiling. And then what is the rate of the successful answer those questions? So in the case of Japan, and the literacy, science literacy of the Japanese adults are much lower in comparison with the other OECD countries. So that when the people are in a junior high school and a high school, their understanding is higher, but when they are grown up, they cannot retain what they have learned in high schools or junior high schools. This is another data. So that this is the main data I'd like to share with you. Several years ago, so the Japanese Society of the Physics conducted this kind of survey toward the graduates and studying the physics. So who were surveyed? So that the people who graduated from so the physics and the department within the past 5 years. And then so that comparing the student, the people who graduated from the physics and the department 15 years ago, as a number, so that interviewed were matched. So that about 3% of the physics and student and graduation in both of the years, in 1989 and in 1999. And the pie chart is a current profession or the vocation. 37% of the surveyed people are engaged in the manufacturing and the education and the communication, 15%, service and the financing, 17%, and the higher education research institution, 14%. So that this is a breakdown of the so that the profession of those interviewed people, surveyed people. So that one of the results of the survey is this: at university, in the so that the hindsight, what was the most useful subject in the university for you? So that the number one answer is the so that the graduation thesis. About 60% of them is mentioned. Red and blue lines. You can see the two lines. So that this is so that the pink shows and the graduates so that of the 5 years ago, and the blue line shows a graduate of the 15 years ago. No difference, but 50 or 60% of them mentioned the most useful one was the graduation thesis. The second most useful, according to them, is the experiment laboratory. Seminars are less popular, about less than 20%, and the same can be said about the exercise, and as well as quantum mechanism and kinetics and statistics and the electromagnetics, and about the answer, so that voting for these subjects are about 20%. So in a nutshell, an experiment, so that the graduation thesis is very much related to the experiment in the laboratory. So that those graduate in physics said the experiments or the laboratory work was quite useful for them. So what does all of the data mean? So our major challenge is that the less motivated students, and there is a deep connection between the less motivated students and the attitudes of the hate science and away from the science, and then this kind of so that the trend give a big impact on the students and a future choice in university, and this would give a great impact on the future of this country. And then according to the survey done by the Physics and Society of Japan, then this shows the positive aspects of the experiment or the laboratory experiment. So in my talk, I'd like to so that further elaborate on the causes of the away from the science attitude, and I'd like to search for some kind of remedy. So what are the causes of the hate science or away from science attitudes? So that they are not identical, but this way, for the convenience of the talk, and I do not differentiate between the two. And sorry, this chart is too busy. So that this shows the science classes hours in elementary and junior high schools. So that this is starting with 1941 up until 2008. So the top part shows an elementary school, and the lower part shows the junior high school. What are the changes of the science class hours in those institutions? So that this is an all subjects hours. For example, there are about 5,600 hours, and from the first until the sixth grader for all of the subjects. In 1958 and in 1977, or so about the total hours, so for the 6 years, it would be about 5,600, but the total hours reduced. In 2002, it is short of the 5,000 hours and 4,949 hours. In 2008, according to the plan, the total number of the class hours will be increased up to 5,200. And when it comes to the class hours of the science during pre-war area, there were about 315, and after the war there are about 500 and 600. But in 2002, it was reduced down to 350 hours, and then last year it was 400 hours. But these science hours are excluding the new subject, that is the life environment and study, so that some of the schools are teaching science in this life environment and study. But the same trend is applicable to junior high school. And in 1941, the total class hours was 3,115, but last year it was dropping to 2,835. And then when it comes to the science and the class hours, and back in 1947, there were 420 hours, but last year it was dropped down to 385 hours. So that this is about the high school, so that the chart 1, chart 2, so that the messages are the same. And what is so that the fraction of the high school students are choosing so that the science or the physics as an optional subject. And maybe chart number 2 is easier in 1978 and 1994. So that there is no difference between 1994 and nowadays. So the black bar shows the fraction of the students choosing physics. So that when I was a high school student, and physics was mandatory, 93% of the students studied physics at a high school. But this physics became an optional subject, and the school curriculum was reformed, and then the fraction of the students studying physics dropped. And the drastic the drop can be seen this so about 30% of the students at the high school are studying physics. So that this and information is misleading, and this is a combination of the old curriculum and the new curriculum. But anyway, about the 30% of the students. And the chemistry, there is a drop, but the drop is not that drop. When it comes to the biology, and no difference, no big difference. But so that the drop of the students and studying physics, so that was very dramatic from the 93% down to 30%. So that you can see the number of the copies of the textbooks, so that this shows the similar information, similar trend. I have to sort of speed up. I am running out of time, sorry. So lesson students are studying so that the physics and the total hours of the science classes have been reduced. Another important factor is the change in the society. As we heard from the audience, so that we are not surrounded by the great nature any longer, and biology teachers. So that deploring, and because students, some of the students have never enjoyed hunting and collecting insects, butterflies or the dragonflies, and the industrial products, manufactured products became really intricate, and they have become a black box. So every year for about the past 30 years, I was in charge of the laboratory education, laboratory classes. About the 10 students are added to the classes every year. But depending upon the age, there were so that boys and who are called radio boys. So that I was sort of a little boy, so that in the era of the vacuum tube and utilizing a vacuum tube, and I created my own radio. And there is an era of the transistor, which era lasted a relatively longer time after I was assigned to Kyoto University. And about 15 years was an era of the transistor. Even there are 10 students on average, and 2 students had an experience of assembling their own radio utilizing transistors. And the transistor era, so that is followed by the ham and the audio students, and this era was very short. And 1980s, there was an era of the personal computers and the students who created their own computers. And there is a first era and a second era. In the first era, their interest in the hardware, starting with the chips, they assembled their own computers. Out of 10 students, and 1 or 2 students created their own computers. In the latter half of the era, so that they purchased a PC from the market, and they install the software in order to modify their personal computers. But nowadays, not so many students who are the mania of anything. I'd like to show you another data. So that this away from the science and a trend can be seen from the decrease in the number of the science-related books that are published in Japan on the left-handed side. And then you can see the percentage of the sort of science-related monthly magazine out of the total monthly magazines. So in the past, the percentage was 30%, but nowadays about 10%. So that this so that the percentage dropped but to 40%. So that I read this article. This is very shocking. And the sales of the science magazine is in Japan is much lower in comparison with the United States. There is a journal called Scientific America, and the Nikkei Science is sold, and this is a Japanese translated version for the Scientific America. And so the blue is a translated version in Japanese. It is dropping, and the red is a Scientific America. And then about the size of the circulation is so much difference, and maybe the size difference is about 10 order, so the 30 to 1. And then the population ratio between the two countries is 2-1. But the question is, if the quality of the translation of the Scientific America to Japan is good or bad. So that, of course, we cannot utilize this ratio difference 1-15 as it is. But anyway, this is a problem. So adults, Japanese, are not so much interested in science, as we can see from the drop of the scientific related journals. So this is a summary. So I think all of the points I have touched so that those points are quite important. So that one important point is that the policy of the Japanese government, so that this hate science and attitude has been triggered by the reform of the curriculum of the schools. And then the number of the class hours have been reduced, and then so that they reduced the hours for the laboratory. So they spent more so that the hours for the memorizing. So that this is a great contributor, so that they have to so that pass the examination to go on to the higher education. That is why the students have to spend more time memorizing instead of spending their time in the laboratory. And then and the another so that problem is that the mothers so that don't so that didn't study so that physics or the science at all. That means the mothers cannot teach the basic science and basic physics to their students or the children. So I think this will start a very vicious cycle. So the mothers can teach the basic physics and science to their children. So if it is not possible, and the children cannot be interested in the science or physics. So that there is another problem, that is censorship of the textbooks. That is a textbook censorship. And Japanese textbooks are very thin. So that this January, this September, I spent a week at the UBC, University of the British Columbia. In front of the building of the Dr. Wyman, there is a bookstore. I visited a bookstore many times. I know what is the situation of the bookstore. At the beginning of the September, there are so many new students. And the physics textbook, so that this is as thick as 7 centimeter. So that those thick textbooks are piled up, and maybe 300 copies. I knew that, but then I experienced that one more time. And so talking about the physical education at the university, there are textbooks, but textbooks are not so thick. And it is not possible so that for the Japanese professors to expect Japanese students to purchase such a thick textbooks. And the reaction from the students is this. So this is the story of last year. During the the laboratory, so that the class, and when I talked about the gradient, so that so the board will be going to the maximum gradient. So that I told the students, please think about a map. So that there is a Mount Hiei or the Mount Daimon in Kyoto. So that from the top of the great diamond, in which direction the board will be rolling. So this is an analogy I utilize. I asked the students so that have you ever so that climbed up to the top of the Mount Daimon? And many students said no. And we went to the great so the Mount Daimon together. And then top level students, so that they told me, maybe we don't have to purchase a textbook on the physics, and I can so that I utilize on a website in order to gather the information. So the students do not have an custom to purchase textbooks. So the publishers, they are financially struggling, so that the publisher of the Tokyo University, they have a difficulty in selling the textbooks.
ともかく、これがまあ一つの。
But anyway, so the way of thinking about the textbooks are so much different between different countries. And the another sort of factor is a social factor, and this attitude is related to the change in the society, and now younger people have less chance to touch on the nature. And then, even if they obtain the scientific job, their compensation is lower in comparison with the humanity, the related job. How many more minutes do I have? Do I have to stop now? No, the main message will be coming up. So laboratory education in universities. So that there is no good and systematic research concerning the laboratory education in Japan. So, but I'd like to share my personal opinion based upon my personal experiences in the past. There are a number of the challenges, but what is the most problematic? So that the school, so that the educational system cannot be adaptive to the changes of the students. So that the educational system has become weaker and weaker, and there is a bad reform in the liberal arts education system. And then faculty members do not have much time to so that talk with the students. And there was a problem of the deregulation of the University Act. And when it comes to laboratory courses, there are several issues and problems. So that there is a set menu versus a la carte type of courses. And concerning the set menu type course, so that the themes of the laboratory courses are given in advance. So that this is applicable for the first grader and the second grader. And then so that this kind of course can handle many number of the students. The other type is a la carte type. Depending upon the interest, so that the students can choose the themes of the laboratory courses. So that this is applicable for the third grader and the fourth grader, and 1 or 2 themes per year. It is good for the only smaller number of the students. In order to motivate the students, and maybe a la carte type is better, so that, yes, and everybody agrees with that. But under the current university system, so that we cannot tell which is better. So that both of the courses have their own advantages, disadvantages, but they have to satisfy the criteria. And then laboratory course may be rotten. Any one of them can be rotten for many reasons. And then the students have to submit a report after the completion of the experiment in the laboratory, but the students are copying the reports of the other students. So even if we interview, so that we cannot avoid this kind of problem. And teaching staff so that might lose interest in such an old so the laboratory theme and the equipment ages. So the refreshing the equipment or refreshing the themes so that every 5 years is needed, but it requires money and manpowers because thinking about a new laboratory theme is really a major task. And then teaching staff is not so enthusiastic about such a reform if those experiments are for a first grader and a second grader. And another point, another criteria is that we need to provide students with the successful experiments. And Dr. Wyman so that mentioned that challenging and doable tasks have to be provided to the students. In the case of the a la carte so that type laboratory courses, and so that these courses may not be rotten, but in experiments can fail. But of course, we can learn from the failure, but from educational efficiency. So if students can experience a success, it is more so that successful. And then why they fail, so that the teaching staff should be kept accountable, because they don't care if students are successful or not successful, and then the themes are not appropriate, and the teaching staff fail to provide a good guidance. And then for at the university undergraduate level, so that maybe established themes are better than the fashionable ones. For the latest and fashionable themes, and the faculty members don't know what is the best methodology, so that to test this, or the expected result are not known. So in order to adapt to the current situation, and we have to put emphasis on the basics. So that for the first grader, and maybe a set menu would be better. So if we have more time, so that we can refresh the themes at a certain interval. Experiment laboratory is very costly. And then the students are much inexperienced, and the university has to address that. So that this is very debatable. So personally, so that we so that adapt the level of the lecture to the level of the so that the students, even if the level of the lecture might be lowered, so that we have to sort of make up for the lack of understanding of the students, so that every student can understand the lecture. But the problem is that highly motivated and highly capable students might find the lecture very boring. So how to address this issue? So as an option, we would offer a la carte so the laboratory menu. But anyway, in order to do this, manpower and the money is needed. So that this is the data from the so that website of the Ministry of the Education. And this is the budget in education and the percentage of the spending, so that in the education, so that the out of the GDP. So that this is a survey among the OECD. Japan's ranking is very low, and especially public spending in the higher education, like universities. So that Japan's spending is the 50% of the average, or in comparison with Finland and Denmark and high-scored countries, and the spending of Japan is the so the 1/3 or something. So that this is so the newspaper of the 2 to 3 days ago. So that this is an editorial of the one of the newspapers. And the public spending in the education, so that for the GDP is 3.3%. So among the OECD 28 countries, and Japan's position is so that the third from the bottom. So that the Japan's public spending, so that in the elementary school is 2.8%, but when it comes to the public spending in the universities, and this is 0.8%, so that making Japan at the bottom in the ranking of the OECD. So, so that in order to make up for the insufficient public spending, so that the parents have to spend their own money out of their pockets. So the working hours of the so that the students of the elementary, junior, and high school, but then they are spending more hours in comparison with so that the other OECD countries. So this is a summary. so that the hate science and a trend and away from the science and giving a bad influence upon the society as well as the university. So the children lost their interest in the nature and they are less motivated about learning. And then I think the laboratory education then can be the great and a breakthrough. And we need to study more about what is the best practice of the laboratory education. So that the policy of the government is quite important, but there are many actions which can be taken by the universities. And the universities have to allocate more resources to education, and then a more solid system for the liberal arts curriculum, especially laboratory education is needed, and then a curriculum has to be reformed so that it will be fitting a present day situation. And we need to pay more attention to the elementary and the secondary education. Thank you very much.